Today I am going to discuss the D-transposition of great arteries. D means dextro, transposition means aorta is coming from right ventricle and pulmonary artery coming from left ventricle, that is abnormal, that is reversed. So that is D, trans means abnormal, position means position. So this abnormal, what you see in this image, this is left atrium, left ventricle, and then that is pulmonary artery. How do you identify this pulmonary artery? Because when the aorta rises, it starts moving anteriorly, but in this case it is moving posteriorly. What is it? This is posteriorly, so that is pulmonary artery. Second thing, you can see intermittently the aorta coming out from right ventricle, so that is both aorta and pulmonary artery in one view. You can see in one view, in both are either long axis, it means both are parallel. When you see both are parallel, it means both are seen either in long axis or either in short axis together. That means the case is transposition of great arteries. At the same time, you can see the BSD. So what you see here, you see pulmonary artery that is going downwards instead of going upwards, because aorta could have gone upwards, but in case of pulmonary it is going downwards. And then aorta, both pulmonary artery and aorta is seen in long axis, but in one image. That means they are having deep transposition of great arteries. Now coming to the next image, you can see the ASD. Lower one image is the left atrium, upper one is the right atrium. You can see ASD. In this image, again you see how the pulmonary artery coming from left ventricle and going downwards towards inferior or posteriorly, you say. There is BSD in this image also. Now you can see this is again the posterior secondum ASD. If you want to say the flow in posterior secondum ASD, that is from left atrium to right atrium, that is from left to right. In case of BSD, in this in-phase patient, BSD flow was from right to left, right ventricle to left ventricle. So ultimately it is mixing well. In case of D-transposition, there must be either ASD, BSD or PDA for babies to survive. So in this case, what do we see? Again you see pulmonary artery coming from left ventricle, subpulmonary BSD. Pulmonary artery as is coming from, it comes from left ventricle, it goes downwards in image, or you can say goes immediately posteriorly. But in case of aorta, what happens when the aorta rises from the left ventricle, then it goes upwards. So aorta is going from posterior to anterior. In case of pulmonary artery, going anterior to posterior. That is the difference. When aorta rises from left ventricle, then it goes anteriorly. When pulmonary artery rises from left ventricle, it goes posteriorly. So this is the way to diagnose D-transposition of great arteries. In that case, aorta is coming from right ventricle or pulmonary artery, and pulmonary artery coming from left ventricle. You can say this is clearly. Flow, you can see this is flow in pulmonary artery, this is flow in BSD, that is flow blue in color. The flow is going from right ventricle to left ventricle. Then the ASD flow, that flow from left atrium to right atrium, that is normal flow, left to right flow. Now you can see this is the BSD, this is a pulmonary artery coming from left ventricle. You can clearly see this is main pulmonary artery, this is the pulmonary branches, and this is cross sectional view of descending aorta. Again you see this is ASD, this is fourth chamber view. Fourth chamber view orientation, if you see AV concordance, that is the normal concordance. AV is concordant, it means right atrium to right ventricle, left atrium to left ventricle. In this image you can see the tricuspid valve is more towards apex, and that is the feature of right ventricle. Again you see this DST has flow from right ventricle to left ventricle, that is right to left flow. You can see the flow that is coming from the right ventricle towards left ventricle and then into pulmonary artery. This is the flow in pulmonary artery. So overall this is the image, like short. This is what you see. This is what pulmonary artery.